Hello everyone, welcome back to Let's Unbound. So we are in 2.7 of Unit 2, Concept Review plus Problem Solving. So this is about composition of functions and it will be simple analytical way of solving and exploring things. So be ready with pen and paper and here we go. So what is composition of functions? That means combining two functions into single one. Like you are squaring and your like x is there, you're adding an input, then that adding input is your output, right? For example, x plus 4. Now, adding 4 is a function. Here, squaring is going to be a function. So x plus 4 whole square. So this is called composing two functions into one. And how we will notate this? Two function names f, composite that circle symbol g of x. And that means f of g of x. Like g of x act as input. Like for g of x, x is an input. And then for f, g of x is the input. So that is how it acts. And here one important thing is the order matters. F composition g of x, it's not equal to g. If you put g, then you g composition f of x. It's not equal in general, but we can make some relations where they will be equal. Okay, so in general, they are not equal. And of course, for this composite function, the domain depends on both. It doesn't depend on one. So we should consider both of them when you are describing a domain. Now, how to compose? So you should apply G first. Whatever inside, you should apply that first. Then apply F to your result. So inside first, outside next. That's the thing. And here, decomposing functions. So we know composing two into one. So now one single function, we will break down what are the two functions they made up of. So breaking a complicated into two or more simpler function. So it's just undoing the process. So if you have a one h of x, write it as composition of two functions. So what are the f of x and h of x? Sorry, f of x and g of x. That is decomposing. So one simple example for decomposing is this is a complicated function. Yes, this can be broken down into two functions. So let me name h of x and g of x. Okay, the inside, let me name it as 2x plus 4. Outside is the next whole power 4. So you can't put that power 4. H of x, right? So that also has x as an input, x power 4. Now, order important. If you think f of x is, let me think, okay, maybe it's g of h of x. Let's see. G means g of, first you will put h of x power 4. Then in g function, you will replace x with you will replace x with x power 4. So 2x power 4 plus 4. This is not my f of x. So that's why order matters. So f of x is h composite g of x is the correct order. So now if you do h of, what is g of x 2x plus 4? Now h of x is x raised to the power 4. But now my x is 2x plus 4. So 2x plus 4 whole raised to the power 4. That gives you. So your f of x is h composition g of x. Your h is this. And your g is 2x plus 4. This is how we will decompose two functions. Like, now, we should remember this. Generally, f, it's not commutative. F composition g is not equal to g composition f in general. And domain, if it's a function something like this, f of g of x, first I will check your x should, domain is x values, must be in domain of g. And also, the g of x should be, obey the domain of f, right? So that is how it will be. But it's very simple. It sounds complicated. When you see, you will easily reason it out. And we will solve some problems. Now, here into the first question. F of x is this, g of x is this. Find f composition g of x, and also it states its domain. Simple. Let's move. Let's solve this. F composition g of x means you will write it as f of g of x. Okay. So first you work inside f of, what is g of x root x? I know what is f of x. What is f of root x? You replace your x with root x. That's the thing. F of x, f of root x. So 3 times root x minus 1. This is f composition g. Now state its domain. First you have to check the f composition g is x greater than or equal to 0. It cannot be negative because under the root, right? But also you should check with g of x. Yeah, g of x also can obey this. Also check with f of x, that also obeys. So this is your final domain. And let's do g composition f of x. Which is g of f of x. First inside g of your f of x is 3x minus 1. What is the g of x function? Square root your input. Your input is this. The square root 3x minus 1. Can you see the difference? And coming to the domain. So domain of g composition f is under the root should be greater than or equal to 0. So let's solve x greater than or 3x greater than or equal to 1, x greater than or equal to 1 by 3. And also you have to check with their input. Will this okay with your f of x? Yes, f of x is all real. So even this restriction is fine, right? So that's it. This is the domain of f of like f composition g and g composition. Right. Now moving to question number 2. Let f of x be 2x squared minus 3 and h of x is f composition g of x. Fill in the table. So h of x is f of g of x. What is your, we know g of x, but what is f of x? It's not there, but still we can solve. Yeah, f of x is given here, but not in table of values. Okay, so now if you want to fill in the table, you want h of negative 4. How can I solve it? H of negative 4 means f of g of negative 4. Do you know what is g of negative 4? Yes. Negative 4, this is g of negative 4, right? So we can plug in that f of 0. How can I find f of 0? I have the readily function like, so 2 times 0 square minus 3, just negative 3. So it's negative 3 here. Okay. Similarly, we should do h of negative 2, you need to find, which is f of g of negative 2. G of negative 2 is this 3. Then 2 times 3 square minus 3, which is 2 times 9, 18, 18 minus 3, 50. And here we go. Same thing, h of 1, which is f of g of 1, right? Equal to f of negative 1. Actually, it's f of 3. F of negative 1 and 2 times negative 1 square negative 3, which is 2 minus 3 is negative 1. So that's it. Okay. So otherwise you can do if h of x is nothing but f of 0, directly also you can do. But I'm just explaining how this process works. And f of x values. H of x is f of gx. So if you want h of 0, f of 0. H of 3, right? H of negative 4, it's f of 0. H of negative 2, it's f of 3. H of 1, it's f of negative 1. Directly also you can imply that. Okay, so that's it. Question number 2. It's negative 3, 15, and negative 1. And into the last part. Let f of x be this, ax plus 2, and g of x be this, bx, here, bx minus 2. A and b are real constants. Suppose that f composition g is g composition f for all real x. Which of the following must be true with a and b? Okay, so let's start with the relation. F composition g means f of g of x is equal to g of f of x, right? And f of, what is your g of x? It's bx minus 2. And g of, what is your f of x? Ax plus 2, right? So f of bx minus 2, how will you find it? In f, right? F of x, wherever x comes, will be replaced with bx minus 2. So a times bx minus 2 plus 2. And g of ax plus 2 means in g, x will be replaced with ax plus 2. And simplify, make a relation. So abx minus 2a plus 2 equal to, again, if you take this, abx plus 2a minus, 2b minus 2. So the abx is common and with same sign but in opposite things. So same sign, opposite sides cancelled. Okay, we need to make a relation with a and b, right? So let's take the 2 common. So I got minus a plus 1. Here also I can take 2 common, b minus 1. 2 to cancel, minus a plus 1 is b minus 1. We can take this here. Minus a equal to b minus 2. Minus 1 minus 1 minus 2. Okay, let's make a equal to 2 minus b. So yes, I can see that here, right? So a equal to 2 minus b is a relation we got. That's it. And also, I have a bonus question to you. So take a screenshot of this. It's a simple modeling with composite, like a real world problem. And we apply composition here, right? Very simple. And I hope you have taken the screenshot. So moving to next. Yes, signing off for today's video. I will be meeting you in next video very soon. Until then, keep learning. And if you want to join student community of Let's and More, you can scan the QR code given here. Thank you. Keep learning, keep practicing, and stay curious.